Next, I want to take some time and talk about reference angles. So here's a new definition. Let theta be a non-acute angle, so something bigger than 90 degrees in standard position that lies in a quadrant. So the terminal side actually has to lie in a quadrant. Its reference angle is the positive acute angle theta prime formed by the terminal side of theta and the x-axis. So theta prime is always going to be acute, meaning less than 90 degrees, and it is formed by using the x-axis, either side of the x-axis. So for instance, here's when we have our terminal angle in quadrant 2. And what happens is that reference angle is just the angle left over to get down to the x-axis. So it's this little pink angle here. Let's say that your terminal side is in quadrant 3. Now, it has to be less than 90 degrees, so the closest x-axis side is the negative side. So you would go up to the negative side. So this little piece here is going to be that reference angle. And then over here, if you're in the fourth quadrant, again, you're going almost all the way around, but you're going to form the reference angle with the positive side here, heading up. So that is what your reference angle is in each case. So let's do some practice with that first. So find the reference angle theta prime for each theta. Now, this is one where I really do recommend the visual here. Now, remember, all the way around the circle is 360 degrees. So you have, so we're starting here, standard position. This is 90 degrees, 180 degrees, 270 degrees. Now 340 is obviously bigger, but remember 360 is the whole way, so we're not going quite the whole way. So maybe like right here. So our terminal side is coming out like this, and this is our theta going around. So our theta is 340 degrees. Now your reference angle is going to be that small angle that connects with the x-axis. So here, my closest x-axis is the positive side. So this is going to be my reference angle. Remember that the whole thing around is 360, and we've made it 340 degrees. So I can actually just define this angle, take 360 and minus that 340, and I get 20 degrees. So that is my reference angle here. When you have something in quadrant 4, this is a good technique because you're almost all the way around. So using that 360 degrees or 2 pi if you're in radian form is really easy to subtract with. And that's a way that you can get that fourth quadrant value. For the second one, we're using radians. And again, so you need to, I would draw the picture first. I think that is really helpful for these problems. And maybe a little bit harder. So you think about it for a second. 90 degrees is the same as pi over 2. And if you think about this, this is bigger than pi over 2, right? This would have to be 3 pi over 6 to simplify to pi over 2. So we're bigger than that. So we're definitely, you know, up here. And then if I go the full one next, that's 180 degrees, that is pi. Now that's gonna be a little too big because this is 5 pi over 6. So that's less than 1 pi, right? It'd have to be 6 over 6 to be 1. So we're going somewhere maybe here in the second quadrant. So we're in that second quadrant here. So this is going to be your reference angle. And a good way when you're in the second quadrant is to think that, well, this straight edge forms 180 degrees. We're not quite at 180 degrees, right? We're almost there. So in radians, that would be pi. So a good way to do this is to just take our pi and subtract the 5 pi over 6. Or again, if you don't have pi, you'll be doing 180 degrees here. You do need common denominator, so this would be 6 pi over 6 would be a whole, minus 5 pi over 6, and I get just 1 pi over 6, or pi over 6 in this case. So here our theta prime was 20 degrees, here our theta prime is pi over 6 radians. So the next one, negative 135 degrees. All right, so we're still starting on the positive side. Now you're going in the negative direction, so I'm going to go backwards here and go down. So the first one I come to would be 90 degrees, so negative 90 degrees now. And if I went the full next group, it'd be negative 180. That's too far. So we're somewhere here in the third quadrant. And again, so here's going to be our reference angle. We're going again to the closest part of the x-axis. You want to have a nice small angle there that's less than 90 degrees. So this is one way to do it. Now, what you can think about here, and again, there's different ways to think of it. They're kind of like little puzzles. I'm noticing I'm in the third quadrant here. So on the bottom, this total, so if I forget about the top for a second, there's 180 degrees here, right? Technically, it's negative 180 degrees because we're going in the negative direction, but you have 180 degrees there. So we could do 180 degrees minus that 135 degrees. And when I do that, let's see, I get 45 degrees. So my reference angle here would be 45 degrees. So again, I'm subtracting with 180. Again, I know I'm going in the opposite direction for the negative, but I'm not really worrying about that. I'm just thinking about 180 degrees altogether. So if I have 135 plus 45, that gives me the 180. Remember, your reference angle is going to be positive, and it's going to be acute. So it's very specific that we do want the positive version, not the negative. All right, and let me do one more. I'll try to squeeze it in here. Now this last one's a little bit weird. It's theta equals 2.5. There's no degree symbol, so this must be radians. So you want to be careful here. It's not 2.5 degrees. It would be 2.5 radians. And it's kind of like, ooh, where's my pi, right? I don't know what that is. So I'm going to take out my calculator for a second. And I'm going to remember that, well, the 90 degrees would be pi over, this is pi over 2, right? So if I did pi over 2 as a decimal, divided by 2, I get about 1.57. Well, 2.5 is bigger than that. So my next stop would be pi, right? And pi, hopefully you know that one, but pi is about 3.14, which is too big. So 2.5 is going to be somewhere in between. So here they're just giving you the decimal version instead of the kind of pi notation. So our theta is going to be something like this. And then that means this will be our reference angle. Now, I'm in radians, so I'm going to use the radians idea. And again, I know that this whole top would be 180 degrees or pi in radians. So I'm going to take that pi and I'm going to subtract the 2.5. And you're just using your calculator there, right? Because they're not really giving you the exact value. So if I plug it into my calculator and I take that pi, which I already have in, and I minus 2.5, I get about 0.64, we'll say 2. So that would be my answer there. 0.642, again, that is in radians. I went into a couple more examples with these reference angles. So the ones we saw so far were between 0 and 360 degrees or 0 and 2 pi. What if you have something that's beyond that? So let's say, for example, I had something like theta equal to 580 degrees instead. What I would recommend doing here is to, first of all, getting it between 0 and 360. So what you can do is you can take that 580 degrees and we can subtract out 360 degrees. And you're left with 220 degrees. So basically, you're just taking out that extra rotation that you don't need because your terminal side is still going to be the same. And you want to do that process as many times as you need to get something that only has one rotation. So we can go ahead and do this. And again, remember, these were coterminal angles. We talked about this before. So there's nothing wrong with taking out that 360. You're still going to have the same terminal side. It's just that you're taking out those extra rotations that you don't need. All right, so here is my 0 starting point. All right, 90 degrees, 180 degrees. The next one's 270, so it's going to be somewhere like here. Just going to kind of draw that picture. So this would be my reference angle. Again, I kind of remember that, well, this piece here is 180, right, the top half. So if I need the little piece in between, I could take that 220 and subtract the 180. And then I'm left with, what, 40 degrees here. So my reference angle there is 40 degrees. For me, when I'm finding reference angles, I draw the picture, and a lot of times you're either subtracting with 360 if you're in the fourth quadrant, that's usually the only time, or if you're in the other quadrants, you're probably subtracting with 180 because you're kind of using that straight edge as that main piece. So here I'm kind of saying, well, what if I take away this first top half, then I have just the reference angle, right? So I'm taking out that 180 degrees. You can also do it with radians. So let's say I have something, I'll do another negative here, negative 13 pi over 6. Now, this is more than one full rotation. It's negative, so it's going the other direction, but if you think about it, right, 2 pi is a full rotation around. And if I was in 6, that would be 12 pi over 6. So I'm going more than a full rotation. So what's happening here is, again, I'm going to get rid of one of those rotations. Because it's negative, in this case, to find the coterminal angle, I'm going to add the 2 pi. Oops, I just wrote that twice. So 12 pi over 6. Then I have negative pi over 6 instead. Now, if you want to, you could actually add another 2 pi if you want to start with a positive angle instead. So remember, with coterminal angles, you can keep adding or subtracting 2 pi or 360 degrees as many times as you need to. So this is not a positive angle yet, right? It's still a negative angle. But that's okay. We can still go ahead and work with that negative angle here and go ahead and draw it. Okay. So think about it for a second. You're starting here, you're going negative, so you're going the opposite direction. If I'm going down one group, this would be negative pi over 2, so negative 90 degrees. Pi over 6 is smaller than that, so it's staying in this fourth quadrant here. So maybe it's like right here. And this is my theta, negative pi over 6. Now this is kind of a nice, easy reference angle here, because I didn't keep adding 2 pi to make it positive. If I made it positive, it would have been this angle here. I just decided to keep it negative because my answer wasn't to find the coterminal side, it was to find the reference angle. So I actually have my reference angle. This is my reference angle right here, and it's the same exact size, but I want it to be positive. So my reference angle in this case is just pi over 6, because again, I'm comparing this with my positive axis, but I want the positive version. So this is a nice, easy one where I'm able to just switch it to the positive sign because it's that same angle, the same shape, the same degrees that we have. And this is one way to do it. Again, another way would be to go ahead and add another 2 pi here. I'll just make a little side note, right? So if you did it that way, we can take this again and add another 2 pi. So you end up with 11 pi over 6. And what would happen here in that case is your angle would be this way. So you'd have theta equals 11 pi over 6 like that. And then you're still getting the same reference angle. And when it's in the fourth quadrant, the easiest thing to do to find the reference angle when you're going all the way around is to add or subtract with 2 pi. So for the reference angle there, I would do 2 pi minus that 11 pi over 6. And you have, again, pi over 6. So you have the same value here. I'm just taking it the full way with the coterminal angles. But if you're just finding a reference angle, then as long as you can draw that picture easily, then you're okay and you can take it from there.